Hello, chemistry fans, and welcome back to Chemistry 1032 Problem Solving Session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I will be guiding you through this problem today. So let's jump at it. Drawn below is the molecule sucrose. Table sugar, actually. This is table sugar, in case you haven't seen it before. Circle the anomeric carbons, square the glycosidic bond, describe the glycosidic bond. Okay, so it's like problem 9, only slightly different. So first things first, let's do the easy stuff. The anomeric carbon. The anomeric carbon is, anyone? All right, you got it. It is the carbon that is directly to the right of the oxygen in the ring. So oxygen in the ring, one carbon to the right, anomeric carbon. Oxygen in the ring, one carbon to the right, anomeric carbon. So that is the first step. Circle the anomeric carbon. Square the glycosidic bond. Now remember, the glycosidic bond is an ether bond that connects two sugars. So here we have sugar number 1, sugar number 2, connected via this ether bond right here. So let's put a square around that. It'll look more like a rectangle, I think, but let's just do it. There we go. There's our glycosidic bond. Now, we have to number the carbons in the Haworth structure. The top one is a 6-membered ring, so we just easily do that. Carbon number 1, 2, 3, 4, 5, 6. We've already seen how to do that. Now that bottom one, that bottom ring, that's a 5-membered ring. So how do we number that? Well, we have to start here at the carbon that's outside the ring. So this is carbon 1 right here. This is actually carbon 2. So keep that in mind. If it's a 5-membered ring, you start numbering at the carbon that's just outside the ring. This carbon will always be here. Okay? There will always be a carbon outside the ring, and that's always carbon 1. To the right of the oxygen, and that carbon is number 1. This one is 2, 3, 4, 5, 6. The only thing confusing here really is that this is not carbon 1, it's carbon 2, because it's a 5-membered ring. Carbon 1 is here, carbon 2 is there. It's a little confusing, I know. One more time. This is carbon 1, carbon 2, 3, 4, 5, 6. Carbon 1 is outside the ring in a 5-membered ring. In the 6-membered ring, carbon 1 is inside the ring. Carbon 1 is on the outside of a 5-membered ring. Okay? Now, to describe this glycosidic bond, we have to now tell if it's alpha or beta. And to do that, we have to find the anomeric carbon. But now, wait a second now. This anomeric carbon and that anomeric carbon are both part of the glycosidic bond. Things just get more complicated as we go along, don't they? So wait a minute now. The glycosidic bond is actually between two anomeric carbons. See the circles? Those are my anomeric carbons. The glycosidic bond is between the two of them. All right? So we have to describe both. I know, it's weird, right? We have to describe both. So according to the top ring, if we just ignore this, this is down. The oxygen's down. So that is alpha. If we take into consideration just the bottom ring, the oxygen here is pointing up. That's beta. So this glycosidic bond, depending on the point of view, is both alpha and beta, depending on how you look at it. So we actually have to say that this is an alpha, comma, beta. Why? Because according to this ring, the glycosidic bond is alpha. According to this ring, it's beta. So it depends on how you look at it. So we have to say both. It's alpha and it's beta. Dash carbon 1, comma, carbon 2, glycosidic bond. All right? Now that was a complicated one. That's more complicated than probably you'll ever see on an exam, but this is the most common sugar in our society. So probably might want to know how to name the glycosidic bond. It's an alpha, comma, beta, 1, 2, glycosidic bond. All right? If you still have trouble with that and you can't quite figure out how to do that, do not hesitate to contact one of the tutors here at the Academic Success Center. They are here to help you. Or come on by and see your professor during normal office hours. And with that, I bid you good luck and good chemistry.